Hello everyone, in this video we'll talk about uncertainty propagation. Before watching this video, make sure you watch the part 1. The link is given in the description below. So let's get started. So I have the values of length over here and the respective values of time period for one oscillation. And in the last video we discussed that t is directly proportional to square of the root length. That implies t square is directly proportional to length. So I'm going to plot a graph between square of the time period and length. For that I have a simple table which only includes the values of length and t square. So let me insert the graph, scatter plot, yes. Let me include the line of best fit as well, chart element, trend line, linear, right? So what I've got is a straight line, right? A straight line which shows the relationship between length and t square. I have got a line like this. So step 1, let us find out the amount of random error involved in our experiment. For that, what I have to do is I just need to find out the difference between the true value, basically the coordinate on the line of best fit, and the measured value that may be either above the line of best fit or below the line of best fit. So difference between the values obtained from line of best fit and the values that you obtained from the experiment gives you the amount of random error. So let us see this. We have length values over here along with the t square values that are obtained from the experiment, and these are the values of t square that are obtained from the line equation that we have, and these are the values of difference between the experimental value and the values from the line equation. So simply I just did is subtracting the cell values C44 and D44 and applied the same formula for the rest of the cells. Next, I wanted the percentage difference, which is basically difference divided by average of these two values over here. That's what you can see. The equation is E44 divided by average of C44 to D44, right? So that gives me difference, percentage difference in the values over here. And if I calculate the average is basically I've used the function average and from F44 to F51. So when I calculate the average, I found it to be 0.02%, which is very much small or negligibly small, and we can say it's about 0, right? So this gives an understanding that in our experiment we had a very less random error involved. Perfect. Let's talk about uncertainty calculation in this experiment. So what do you mean by uncertainty calculation? Uncertainty is basically the doubt of error associated with your measurement value, right? So as you can see, I have values of length, and these are the trial the time period 5 oscillations. So I've done for 3 trials, and this is my average time period for 5 oscillation, and this is the time period for 1 oscillation. Excellent. So let us find out absolute uncertainty in the time period for 1 oscillation. So I can do either by using standard deviation, or I can use max minus min by 2 formula. I have done both, but I'll follow standard deviation values for the rest of my analysis in this video. But anyhow, I want to show both the ways. So standard deviation, you can simply use the function STDEV, which stands for standard deviation. And I've selected the range from C70 to E70 over here, starting from this cell to this cell. And as soon as you click enter, it calculates the standard deviation value. And that is basically your absolute uncertainty in the time period for 1 oscillation. Similarly, I have done max minus min by 2 calculation as well, as you can see over here. So max in the bracket, the range of values, minus min, again the range of values that I have over here, divided by 2. So this also gives me uncertainty in time period, or absolute uncertainty in the time period. So anyhow, as I said, I'll follow only standard deviation for the rest of the videos, rest of my video over here. So I have the values of length back again, copy pasted from the above, and I have values of t square. But this uncertainty that I've calculated is the absolute uncertainty in the time period, but I wanted absolute uncertainty in the t square. So let me show a small calculation over here. So say if you have uncertainty in the time period, uncertainty in t square can be calculated by using fractional uncertainty calculation, which is delta t square by t square equals 2 times delta t by t. That implies delta t square equals 2 times delta t by t times t square, which is equals to 2 times delta t times t. So to find out the absolute uncertainty in t square, I have to do a simple calculation, which is 2 times delta t times t. That's what I've done over here. 2 times delta t times, where is delta t? Delta t is in the cell H 70 over here, right? H 70 over here, whereas times t is in the cell G70 over here. So that's what I've done. I just use the cell values. Next, similarly, I've applied for the rest of the cell 2 times H77 times U77. So this column is basically my absolute uncertainty of square of the time period for one oscillation. Now let me plot the graph between L and T square. Select the data, click on insert, chart, scatter plot. That's my graph. And let me include the uncertainty in the bar graph, in my graph over here. So we include with the help of error bars. So let me double click on the data point, add chart element, error bar, standard error. So standard error is by default system gives a constant error for every single data point on graph, but I wanted my values, my custom values, right? So let me double click on the vertical error bar and click on custom, specify value. My values are over here. So positive values are all these. Next, negative values are also same, these values only. So click on OK, and you can see my error bars value have changed. Anyhow, I don't want the horizontal error bars, so let me delete from the axis over here. So when I enlarge the graph, when I maximize the graph, you can see the error bars can be seen very clearly over here. So what I've got over here is basically the error bars or represent the uncertainty in the t-square. Now, the final equation that I'm going to get is y equals mx plus c. You people know about this, right? Y stands for dependent variable and x stands for independent variable. And the relationship between y and x can be determined from this equation, y equals mx plus c. But this doesn't include the uncertainty values. So let me include uncertainty as well, which is y equals m plus or minus delta m times x plus c plus or minus delta c. So what is delta m over here? That is uncertainty in the slope, and delta c is basically the uncertainty in the intercept. So to find out uncertainty in the slope or uncertainty in the intercept, I need to draw two graphs in the same graph in front of you. The two graphs are two line of best fit. Basically, I have to plot a line with the maximum slope and the line with the minimum slope. So how do we draw? Let me again draw it on the board. So take an example. I have a line of best fit which is there in front of you, which has two coordinates a and b, right? So a corresponds for the length 0.30, whereas b corresponds for the length 1.00. And for the length 0.30, my t-square value is 1.27. For length 1.00, my t-square value is 4.03. Now, if to draw the line with a maximum slope, I'm going to join the lower error bar of coordinate A to the upper error bar of coordinate B. So the line joining this two points is going to give me a line with a maximum slope. I'm going to call this coordinate over here as x and this coordinate over here as y. How can I get the coordinate x? Simply, I'm going to subtract the value t square with the error bar length. Over here, I'm going to add the value of t square with the error bar length. Very simple, right? Now, how do I get the minimum line, or also known as line with minimum slope? For that, I'm going to take this coordinate, I'll call it as w, and this coordinate, I'll call it as v. The line joining w and v is going to give me a line with a minimum slope. How do I get the coordinate for w? I just need to add the length of uncertainty or length of error bar with t square. Similarly, the coordinate of v can be determined from the t square minus the length of uncertainty, right? If you have understood, let me quickly show on the Excel sheet. So these are the values of L back again, and these are the values of t square, and these are your value of uncertainty in the t square. To draw the max slope line, I need the two coordinates. So that's what do I have over here. I just subtracted the t square values with uncertainty error bar or error bar value, and in this case, the other coordinate, I added the uncertainty with the t square value. Whereas for the minimum slope, similarly, I followed the same steps. I added t square with error bar length, and other coordinate t square with subtracted from error bar length. So what I have over here is I have the coordinates. I have two coordinates for max slope line, and similarly I have two coordinates for minimum slope line. So let's go ahead and plot the max line and min line as well. For that, let me again plot a graph of L and t square. Click on insert, chart, scatter plot, yes. Let me include the trend line, add chart element, trend line, linear. So blue line is basically my line of best fit. Let me include the maximum slope line. For that, I need to come to graph, right click, click on select data, click on plus, and then go ahead and select the x values over here. X values ranges, the x values are basically the values on x axis, going to be the same as going to be length values, right? Yeah, so I've selected the values of x, whereas y values for max slope line will be from here to here, right? Perfect. So I've selected the values of x and y. Click on OK. You can see there are two dot in orange color have plotted on the graph, right? Now I'm going to plot a line of best fit. So chart element, trend line, linear. So perfect. So you can see there is a line of best fit drawn, and that line of best fit is a maximum slope line. Similarly, let's draw a minimum slope line. Again, right click, select data, plus to add more series, because third series I'm adding over here. X values are going to be again my values of length, whereas y values are going to be my minimum slope line values. And then click on, wait, sorry, I think I did a mistake. Let me again select. X values are going to be my values of length, whereas my y values are going to be the values of my min slope line. Perfect. So click on OK. You can see there are other two data points have plotted on the graph, which is in gray color. And if I double click on it, add chart element, trend line, linear. So you can see I have both max slope line and min slope line. So I need the line equation for every single line over here. So let's start with the line of best fit. Click on display equation on the chart. So right top corner, line of best fit equation. Next, display equation on the chart. The right corner is my max slope line. Next, double click gray line, display equation on the chart. The bottom one is the line equation for my minimum slope line. So let me write down the values of everything at the bottom over here. Okay, so I have a max slope, slope of the maximum slope line, and minimum slope stands for slope of the minimum slope line. Let me show you over here. As you can see, this is the slope of this is the slope of the maximum slope line, whereas this is the slope of minimum slope line, right? Perfect. That's what I've noted down over here. Slope of a maximum slope line, slope of a minimum slope line. And if I just do maximum minus minimum by 2 will give me uncertainty in the slope. That's what I've done over here. You can see the values in the cell A155 minus value in the cell 155 divided by 2. That gives me uncertainty in the slope, that which is simply delta m. Similarly, I want to find out delta c, which is uncertainty in the intercept, which means I need to find out the maximum intercept, which is going to be 0.28, right? Maximum intercept 0.28, whereas the minimum intercept is minus 0.12. That's what I've written over here. 0.2 is a maximum intercept, and minus 0.12 is a minimum intercept in this experiment. And delta c, which is basically uncertainty in the intercept, can be determined again simply by using max minus minimum by 2, right? So perfect. I have the values of intercept, uncertainty in the slope. Also I have uncertainty in the intercept. Finally, I can determine the equation in the form of y equals m plus or minus delta m plus c plus or minus delta c. So let me write it on the board over here. So the line equation that I'm going to determine at the end is going to be y equals m plus or minus delta m times x plus c plus or minus delta c. What is y in my experiment? It is square of the time period, equals m. What is my slope? My slope of the line of best fit. My slope of the line of best fit is over here, 3.963 plus or minus the uncertainty in the slope is 0.5, right? Uncertainty in the slope is 0.5. So let me write down over here 0.5 times x plus y-intercept of my line of best fit is 0.0749 plus or minus uncertainty in the intercept is calculated over here, which is 0.2 plus or minus 0.2. So this is my relationship between t square and length. And remember, my x is basically the length of the simple pendulum. So let me replace that x with L, and that's the final equation, or that gives us a final relationship between the square of the time period and the length of the pendulum. As well as this equation also talks about the amount of uncertainty involved in my experiment, uncertainty in the slope as well as uncertainty in the y-intercept. So that's all about in this video.